2020 DEB, paper 1, question 9, you have the acceleration in meters per second of a radio-controlled drone moving in a straight line during a particular time interval can be modelled by this function. Okay, where t is time in seconds after the drone begins to move, and this is the acceleration. So you may want to even put that into words. And time is between 1 and 9 seconds. If the speed of the drone is 1.4 meters per second after 1 second, find its speed after 5 seconds. Well, if we have the formula for acceleration, then we need to integrate. I'm putting that as a power of a half already. And if we integrate, it means we need to add 1 to the power and divide by my new power. Plus c. You can clean that up if you want, or you can just leave it as it is. So I want to hopefully maybe figure out the value of c here. So this is now my formula. I haven't really cleaned up. This is my formula for speed. It's not perfect because I know there's a constant here that I'm just calling plus c at the minute. So let's see if the question gives me more information. The speed of the drone. So speed is 1.4 after 1 second. So when time is 1. So it's not, I can't always find out what c is, but if I can, I will. Throw that into your calculator, work it out, and c is equal to 1.1. Okay, and that just means that my formula for speed, I now have hopefully the perfect version of the formula, let's say, and if you want to, you can even clean it up. 0.1 t squared plus a 0.2 t to the power of 3 over 2, or 1.5, sorry, t to the power 1.5, and my plus 1.1. That's my formula for speed. Now that I've calculated the formula for speed, find its speed after 5 seconds. So t is 5. Anywhere I see a t, throw in a 5, throw it into your calculator, and you get speed of 5.8 meters per second. Find the average. Sorry, I keep hitting off that. Find the average speed of the drone over an interval from 1 to 9. Now, average means, you know, average area, average interval. We're looking for the integration 1 all over b minus a. I'm writing down my formula here. A to b of x dx. So, I mean, you could actually write that in terms of this exact formula if you wanted to. So we need the average speed. So here's my speed formula. And this is 1 to 9. So we're integrating from 1 to 9. So that's 1 all over 9 minus 1. My speed function, 0.1, sorry, 0.1 t squared plus 0.2 t to the power 1.5 plus a 1.1. And this is in terms of t. And I'm only putting that in just so that you know my variable I have here is in terms of t. Okay, so need to integrate this, which means you need to add 1 to the power, divide by your new power. So the 1 all over 8 is still out here. Plus 0.2 t to the power of, I need to add 1 to the power and divide by my new power. Plus 1.1, so it was a t to the 0, so now it's t to the 1, divided by 1 isn't going to do anything, plus c. Now I know once I start subbing in my 1 and my 9 that c is going to cancel out, so that's fine. I don't need to find out what that c is, and that's what it looks like. So you're going to throw in, when t is 9, so t is 9, you throw it in, minus, same thing, when t is 1, and then when you have your answer, you're sort of getting an eighth of that. So when t is 9, I think we end up with 53.64. and 1.2133. Eventually you come out with, and we are to round it to 1 decimal place, 6.6 meters per second. Make sure you put in your units. They're going to take a mark off me at some stage if I don't put in my units. So a chemical process is controlled by the release of a catalyst. So you don't really need to understand that, but maybe, oops, sorry, but maybe if you have, you know, looked at science, you might even have an idea of what a catalyst is, even if they didn't explain it. But don't get thrown by the words. You still have a formula here. And it looks like volume as time changes. So the volume is changing as time goes on. And yeah, the volume of the catalyst released. So the volume is in litres and T is in time in hours from when the catalyst is released. At what rate is the catalyst released in the reaction chamber initially? Well, that's when time is 0, so that's fine. So you get your formula. And all we need to do is anything to the power 0 is 1, so I do my indices first, plus this to the power minus 0, still a 0, is a 1, which gives me 4, and it's litres per hour. Find an expression for the volume. Well, if this is the volume, like the rate of change of the volume, then we need to integrate to find the volume. I'm going to go to my log tables, see how to integrate an E function. Yep. Oops, all right, and it's here, which is great. So if you want to integrate e to the t, you just leave it as e to the t. And if you want to integrate e to the minus t, so minus 1 times t, then it's a plus. Now we need to go 1 over minus 1 e to the minus 1t. I'm just saying there's a minus 1 there. Clean that up. Now plus c, sorry, clean that up, and you have 2 e to the t minus e to the minus t plus c. That's my not so perfect formula for volume. And if we can, we are going to try and figure out what c is. So what do I know? Chemical process, the volume of the catalyst released. So when time is 0, and this is often what we can figure out, when time is 0, the volume is 0. expression. That's not what we have the rate. Yeah, okay. So up here we know that the rate at which it's changing when time is 0 is 4. But if you think about it, it was 0 volume and it went to 4 litres, you know, after 1 hour. That's the rate of change. So if we're looking here, we're saying, like, you know, when t is 0, when the time is 0, at the very start, the volume should be 0. Because we're looking at the reaction or the volume of the catalyst released. Well, if you're at 0 time, then there's no way there's any volume released at 0 time yet, because it's the very, very start. So just hope that you understand the difference between those two. This is asking what's the rate at which the volume is changing initially. And here I'm using the fact that I'm not using the rate of change formula anymore. I've integrated it to find the volume formula. And if you think about it, when I look at the question at time 0, the volume is 0 because it hasn't released any volume yet for me to look at. So volume 0 to e to the 0 minus e to the minus 0 plus c, and I end up with c being 0. So my, hopefully, what I'm calling my perfect formula for volume, 2 e to the t minus e to the minus t. Okay, I'll probably use that at some stage maybe. Okay, given the volume of the catalyst released into the chamber is 3 litres after k hours, we're going to show that. So volume, I'm using my volume formula, 2et minus e to the minus t. So it's 3 litres after k hours. The volume is 3 and the time is k. And hopefully all I need to do is manipulate that around and it'll eventually look like this. So 3 is equal to 2e to the k minus, that's 1 over e to the k. I'm going to multiply everything by e to the k. That gives me 3e to the k is equal to 2 e to the k by e to the k minus a 1. And that gives me 1 over e to the k. So that's 3 e to the k, that's done, is equal to 2 minus a 1. I must have done something there now. So 3 is equal to, I see it. I'm sorry, I've made a mistake back up here. Now this is actually good that they show me where to get this, because I'm always making mistakes and I need to go back and change it. That's a 2 there. That's a 2. There should be a 2 there. And a 2 there. And does that make any difference to my C? No, it doesn't. C is still 0. So my formula is a 2e to the t minus a 2e to the minus t. Okay, that's fine. Now I'm down here. That's a 2, that's a 2, that's a 2, that's a 2, and that's a 2. There we go. Sorry about that. I made a mistake earlier on. And it just, this allowed me to see, right, go back and make sure that you have everything right. So there it is. next bit. Hence find the value of k. Right, hence means I need to go back. Okay, so sorry, 3e to the k is equal to 2e to the 2k minus 2. Alright, so what do I want to do with this? I want to find the value of k, which means I need to solve the equation. Right, I guess I'll start with maybe bringing everything to the left. Okay, so I'm gonna actually, I think, move it around, change my signs a little bit. Sorry, that should be a +2. So if we bring everything to the right, or we just change all our signs, 2e to the 2k plus a 3e to the k plus, no, 2e minus, and that's a -2. Factors of 4 that subtract to give me 3. Well, that's a 4 and a 1. Common, we have 2e to the k so 2e to the k bracket e to the k minus 2 plus 1 e to the k minus 2. Okay, great, this is working out. I'm factorizing. E to the k minus 2 is one factor, and 2e to the k plus 1 is another. Split it down, e to the k is equal to 2. And I'm going to use logs to figure that out, throw it into my calculator, and I should end up with e to the k is equal to 2. Means k is equal to log 2 in the base e. Yeah, should just be able to throw that into your calculator and end up k is equal to 7. Okay, so that is possibly one solution. I'll need to just check that, because that is, hang on, I said something about a minute, and I think I was working in hours, wasn't I? Yeah, so I'm after finding out k that's k hours. They want me to do it in minutes. I need to just be careful of that. And then I'll go over here and I'll solve this one is equal to -1. E to the k is equal to -1/2. And, oh, let me throw that into calculator. Yeah, that's not possible. So I'm going to cross off that solution. So this is my only solution per hour. They've asked me to do it per minute. So I need to just multiply it by 60 so that I can check what it is per minute. Okay, and I end up with 41 point something, and they told me to round off, so that's 42 minutes. I hope that part is okay there. This is an hour. I want to know per minute. So 42, not per hour, sorry, this is it as an hour, which is 42 minutes. Part 5. This seems completely different out of the blue. These are the first 3 terms of an infinite series for e to the x, where the absolute value of x is less than 1. Find an expression for e to the minus x. Well, anywhere I have an x, I'm going to throw in a minus x. So now I have my first x, it's getting replaced by a minus x, plus, now I have another x, it's getting replaced by a minus x, and I'm just going to clean that up. I end up with 1 minus x plus x squared over 2. And all I did was kind of like a function anywhere I saw an x, I put in a minus x into this. And hence right. Okay, so 2 times. So this is e to the x. Plus e to the minus x. Okay, so there's my 2 bracket. Here's my e to the x plus e to the minus x. And I should just be able to clean that up. So that's a 2 plus a 2 x squared over 2, which is equal to, I'm going to multiply that in, 4 plus 4x squared over 2, which is just 4 plus 2x squared. Okay, and use your answer to B part 5 to find an approximation of the volume of the catalyst release into the chamber after log in the base E of 2 hours. So we need to use this in order to okay, so okay, I was wondering. Okay, that's that. Because otherwise that made absolutely no sense to me. So I need to go back here now. dv dt. So I have to go all the way back there. I haven't a clue what that was about. Plus is equal to 2 e to the t. So I've been using that. So this didn't come just out. It kind of did, but it's linked back to earlier on when they eventually got me to work this out. So 2 e to the t plus 2 e to the minus t. That's that. Same. And I'm after saying that that is the same as that. So dv dt is 4 plus 2x squared, except that would be dv dx, I think, because I'm, well, you know, if I'm going for t, that's a t squared. Yeah, that's all. Okay, so volume, that's not a formula for volume, that's the rate of change of volume, so I need to integrate that. 4, add 1 to the power, divide by my new power, plus 2, add 1 to the power, divide by my new power, plus c. And we are going from released after 2 hours. So we need to get that, and we need to integrate it from 0 to ln2. I don't need to figure this out now because I'm going within this time frame here. So 0 ln2. So you're firstly throwing in ln2 anywhere you see a t, get your answer. Then you need to throw in 0 anywhere you see a t, get your answer. And you end up with 2.9946 something, which approximately 3 litres. Don't know, am I supposed to give it exactly or approximately? Find approximation. Okay, well, I'm going to give both anyway. 2.4605 litres, which is approximately 3. I'm going to have both there, so no matter what, I should be getting full marks.